Hello, my name is Manuel Bravo, and today I'll be showing you a small proof-of-concept demo I made using Unreal Engine 4. I'll start by doing a quick walkthrough of the demo, and then breaking down some of the components. So without further ado, let's get started. So as you can see here, I have my Unreal Engine editor open, with my project open, in this nice, tiny little room. Once I hit play, we'll be entered into this tiny little room as a player. Cool. So as you can see here, this is in the first person perspective. We have our cursor, so we know where we're aiming. We have these three nice little floating objects. Looks like there's no gravity enabled. And of course we can interact with these objects. We can throw them up against the wall, they'll bounce around, they'll even bounce against each other. But this wouldn't be much of a demo if it was just us in this tiny little room with these three floating objects. So let's try to get out of here. Doesn't look like there's a way out except for that door, but that door's closed. If I walk up to it, it's still closed. But I see this mysterious light in the center. Let's try to walk into it and see what happens. Oh, will you look at that? The door opened. Let's walk right out. Oh, that didn't work. Maybe if I try to sprint out of here. Nope, looks like we're not fast enough. So, there must be something that can happen with these objects that are here. Let's try picking one up and seeing if they'll activate the door. That one doesn't seem to do the trick. How about this one? Not this one either. That only leaves this tiny little guy. No, and what do you know? This was the key, and it opened the door for us. No going back now. So as we make our way up this staircase, you notice there's a door at the end of it. But there's no objects to open it. I wonder if it'll open on its own. And as you can see, it opened as soon as the player character got close to it. And just like our door before, it closes behind us. So now we've gone from a tiny little room, cramped little room, to a slightly bigger room. I think this would be a good place to show one of the mechanics that I've built into this demo, and that's our shooting. So as you can see, from the player character, I can shoot these pellets. More so the end of the arms. Sorry, there's no gun model. But if you can imagine there's a muzzle there, they'll be shooting out of the muzzle. As you can see, these pellets interact with the world around them. They're bouncing off the walls, bouncing off the floor. And they disappear after a couple of seconds, so as to not clutter our game. Oh, dead end. Looks like I can't go this way. And this way looks blocked off too, but I might be able to jump on top of these boxes to get around. The problem is, I don't know how to jump. Good thing I have this message that pops up right when I need it. Now we know we can press space to jump to get over this obstacle and make it to the end of our little demo. You can jump into the void of space. So as you can see, that was a very short demo, but there's a lot of different components in here that come together to make this demo work. So I'd like to take the time now to walk through some of these components that you just saw in action. I'd like to start with this room that we started in. As you notice, there's a lot of elements at hand here. First, we have these objects that have no gravity, and as soon as that door opens, the gravity is enabled. Then there's the act of opening the door itself with this trigger volume that we have here, and then closing the door with this trigger volume that we have right in front of it. So let's dive right into it. First, let's start with the gravity. So to make this appear as if there's no gravity in this room, what I've gone ahead and done is I've disabled gravity for each of the items here that I've placed in this room as default. From there, we can go to this blueprint class where we have our trigger. This trigger will set a boolean that has a that is called has sound played. So this is the sound of the door opening and closing. If the sound has played, then we want to enable our gravity, meaning that so the sound played, that's true. We enable the gravity. We get all the components in that room. And these are primitive components, and that's how we can distinguish it from the player and other objects in the game. We'll go ahead and enable the gravity for them, and then once the gravity is disabled, so as you saw, if we remove the key or if the player steps off the pressure plate, the objects will stop floating again. We'll apply a small force in the y-axis, which just happens to be up, or vertical axis in the game world, to give the illusion, once again, that the gravity has been disabled and everything is in 0G. So this nifty little blueprint class will get attached to our key here. As you can see, we define our trigger as the door. Since the door has the qualities, has the sound component that will enable and disable the gravity. But how can we get this door to open? To get the door to open, we have a custom C++ class that works in conjunction with our blueprint. Here we can initialize the door to either be a sliding door or a rotating door. So if you noticed in the first room, our door opened by sliding. Pushed a little bit forward and it slid to the side. Our second door rotated. So the nice thing about how this is laid out is that if we want to have multiple doors that behave in different ways in the same world, we don't need to write a separate class for that. We can just set it as a property of the object, whether it is sliding or a rotating door. Here we can check the components that are attached to the door and spit out a message if that component is missing. So if there's no audio, the game will let us know, hey, there's no audio component. That means no audio is going to play. We can also define the actor that opens the door, which in this case will be our player. So we reference the world, we get the first player controller, which in a single player game would be the user controlled character, and we get that pawn. So our pawn will be the actor that triggers that plate. So here in our tick component, we can get the total mass of actors, and we define the mass required to open the door. So the reason why this object here will open the door is because I've given it a specific mass that the other objects don't. So once that object with that mass enters that trigger, the door will open and it'll act as a key. So that's one condition for opening the door. The other condition is if the overlapping actor is that actor that opens that we defined at our begin play, at the start of the game. So if any of these conditions are met, we open the door. We get the time at which the door was last. We get the current time and set that as the time the door was last opened. And we call this leave trigger method, which we'll go into in a bit. So if the door isn't currently being opened, we then take the current game time, check when the door was last opened, and if that's greater than or equal to our close delay, so the time that we should be waiting for the door to close, we'll go ahead and close that door. And I did kind of gloss over this player walk through the door, but that comes in to play at our leave trigger method. So to open the door, we're just setting if it's a sliding door, we're changing the Rx and Y positions. We can set the speed of the door sliding by multiplying it by a custom variable called slide door open speed and multiplying it by delta time. This will ensure that at every frame we're moving at a certain speed. Else, if it's not a sliding door, we're just updating our rotation. As opposed to our location. The same thing goes for the closed door. And of course, we're playing our sound. Our sounds are both open and close. But notice here that we have this variable, has sound played, that links back to our blueprint, as well as checking if we actually have an audio component attached to our door. This is to prevent any errors from being generated or the game from crashing if we try to play an audio component that is null. Here, our total mass of actors just calculates the total mass of all the actors that are currently on the pressure plate. And here we get to our leave trigger. So our leave trigger will trigger if our player has gone past the door. Here we can set player has walked through the door as true. If our actor is overlapping the trigger, and then we can leave. Else, because this is being called at every tick, at every frame, we keep this at false. So that's a quick overview of how the door mechanism works, the trigger works for that door, and how we set our key to open the door, as well as how our player is able to open the door while other objects are not. And the last component here that I'd like to show you is our grabbing component. So as you noticed in the beginning of the demo, we were able to grab the different objects that were floating in the room and move them around, and then let go of them. So at the beginning, when this component is created, we check that we have physics handle, as that's what's going to allow us to grab the object, or to bind the object to us, and set up our input component. So this is going to map our methods to our keys. So as you can see here, we've mapped our methods grab and release to our right mouse button. When we grab an object, the first thing we do is calculate a raycast vector. And what a raycast vector essentially is a line that's perpendicular to the player, facing the direction that the player is facing as well. So in order to do that, we need to get the location of the player and the rotation of the player. From there, we can calculate an endpoint for our vector by adding the location and the rotation vector and multiplying it by an arbitrary reach value. So this reach value is what's going to determine how far out that line is drawn and how far out the player can interact with the objects in the world from where it's currently at. Once we have our endpoint in relation to our player of the line that we're going to draw, we want to get the first physics body in reach. So to get the first physics body in reach, what we're going to want is a result, right? So a hit result. If our line hits something, we want that something. We want the properties of that something so that we can grab it and move it around. But we also want to avoid that line picking the player as actual input. So in order to do that, we can create this trace parameter, this additional trace parameter, where the owner of this grabber class will be ignored. So this is when we're actually going to draw the line. We use the method, we get the world, and we use a method called line trace single by object type. And so what this does is it'll populate our hit object here, our f hit result. So it'll return our target and store it in this f hit result. We'll set a start point to our line, which is going to be our player's location. We've already calculated where our line should end, so that's going to be our endpoint. And then we want to define what kind of objects are going to register as hits. And in this case, we're going to look for collisions with physics bodies. And last but not least, we'll add our trace parameter object in order to ignore the owner of the line, in this case it's our player, because we don't want to be able to grab ourselves. From there we can return the object that we've hit, or the reference to the object that we've hit. So going back to our grab method, we have our component to grab, which is going to be the primitive component of the hit result that we got. And then from there we want to get the actor of that hit result. So to get the actual actor that we hit, and we'll store that in an actor type variable. If an actor was hit, if there's no physics handle, we'll just return out here. We can't do anything without the physics handle. And if there is a physics handle, we'll grab the component at the location, which is our component to grab, our primitive. Doesn't have a specific name. And this object is going to be at the end of our line trace end. So at the end of the line that we just drew. So once we've grabbed an object, you can see here in the tick component, at every frame, if our physics handle has a grabbed component, we're constantly updating our raycast vector, and which in essence will give us an updated light trace end. And our physics handle will update the location of our object at the end of that raycast vector that we're generating. And of course, once we release the mouse button, we release the component. Essentially, we let go of the object. So those are just some of the many components in this demo that come together to work as one complete package. I really hope you enjoyed this demo, and I'd like to thank you for watching.